So now the question is, when exactly does the bulb glow? We have already seen that initially when you do not switch it on, the bulb does not glow, and it glow when you switch it on or when you complete the circuit. So this is known as complete circuit, and where there is no break in between. So that is called a complete circuit. Now the question is, what special happens when the circuit gets completed, and why the bulb was not glowing when the circuit was incomplete? Because the circuit is nothing but like a path for the current to flow. So current needs a path. It needs a road. Let's take one simple example in order to understand what is circuit. Let's suppose you have a bridge, and this bridge connects two places. Let's say it connects town A and town B. So if you want to reach from town A to town B, you need to cross the bridge. So this bridge is actually providing a path to travel from A to B. Now just imagine a situation where a bridge is broken. Now what do you think will happen? The person who is crossing this bridge can reach to some point, say suppose here it reaches to this point, and then there's no path because the bridge is broken. Now since there is no path, do you think the person will be able to reach the town B? No. So the person here is like current or the charges. So the charges will be able to flow only if there's a path. So if the path is broken in between, the current will not be able to flow, right? So the similar thing happens in case of circuit also. When the entire circuit is complete only, then the current will flow through the circuit. And when current flows through the circuit, only then what will happen? The current will be able to reach the filament of the bulb, and that is when the bulb will glow. So every current needs a path to travel, and that path is provided by the electric circuit because the current flows only when the circuit is complete. So now you can understand how your bulb, tube light, fans they start when you switch them on, because the switches are arranged in the circuit in such a way that as soon as you press the switch, the circuit gets completed. And that is how the appliances glow. When you switch it off, the circuit again breaks, and that is why the bulb gets switched off. So that is how it works. So now let's talk about electric circuits, because I'm using the term circuit often. So what is electric circuit? Electric circuit is a path for current to flow. As I was telling you that it is the path required for current to flow. Only when there is a complete path, current will be able to flow. So normally, how do we represent an electric circuit in a um, uh, uh, how do we represent electric circuit? So an electric circuit is represented by a circuit diagram. So we make use of circuit diagrams where we use the special symbols to represent the specific things. So the circuit diagram is drawn using the conventional symbols of different circuit elements. So to represent a circuit, we draw circuit diagrams, and in circuit diagrams, we use conventional symbols for different electrical elements, uh, different circuit elements. Now, what are these circuit elements? These are nothing but the things which are present in a circuit, like battery, bulb, resistors, capacitors, wires. So all these things are like circuit elements. Now, for each circuit element, there is a specific symbol which is used. Now, it's not always possible to draw a circuit where you draw a battery, you draw a resistance, you draw a wire, you draw the entire circuit like that. It's going to consume a lot of time. So, therefore, there are some various symbols which are used for each of these things, and we make use of these symbols to design to design a circuit or to draw a circuit diagram. So let's look at some of the common symbols which are being used. Now, how do we represent wires? Now, wires are represented by the straight lines. How do you represent a cell? You represent a cell like this. So any cell will have a positive terminal and negative terminal, because cells are the sources of electric current. For electric current to flow, you need a positive terminal, you need a negative terminal. So in this cell, you have a longer strand, and that represents positive terminal, and the smaller one represents negative terminal. How do you represent a battery? What is battery, and how are battery and cell different from each other? Battery is like a bigger version of cell. Inside a battery you have multiple cells. So here the combination of multiple cells is actually battery. So the battery will be represented like this. So that means both cells and batteries are the sources of electric current. How do you represent a key? Um, the switch, you can say. So there are two ways of representing a key. A key can be an open key, or a key can be closed. Now, what do we mean by open? Open means the switch is off. And the second option is key is closed. That means the switch is on. Now, open key is represented like this. This is the one way of representing an open key or open switch. So you can see there's a breakage in here in the key. Now if it's closed like this, in that case it will be a straight line, and that means it's closed, so the circuit gets completed. So that is one way of representing open switch and closed switch. Another way of representing open switch and closed switch is like this. This is the open switch, open key, and this is the closed one. And for bulb you use any one of the symbol from these are the symbols for bulb. So these are some of the common things which we will be using as of now. As you go to your higher classes, you will get to know about the other circuit elements also, like resistances, capacitors, voltmeter, ammeter, etc. So right now we'll consider these simple symbols. Now let's try to draw a simple circuit using these symbols. Let's try to draw the same circuit where you have a bulb, battery connected to the bulb, and you have a key. So how will you connect it? So see, this is your battery, and this is the bulb, and this is the key. Now if it is like this, it is an open switch. That means the switch is not on, switch is off. But if it's like this, that means key is closed, switch is on, and the bulb will start glowing. So this is how you will connect it. You will connect it with wires. These straight lines are nothing but wires. And battery or cell, here it is a battery, and you are having two terminals. This is positive terminal and this is the negative terminal. And you will have, this is a key, or you can say switch, and this is how you can connect it, right? So now when the key is open, that is switch is off, bulb is not glowing. Now as soon as you switch it on, it will become like this, right, straight line, and the bulb will start to glow. So this is how we draw a circuit diagrams.